So this is an app that I run on Heroku, and I have added the New Relic APM add-on. APM is Application Performance Monitoring. And if I look at the app being monitored, I can get all kinds of useful information. This is an app that's in production now. So, users are using it. Here's a few interesting things that I can see about the app. I can see that, in sort of the last monitoring interval here, if I'm looking at some of these requests, each sort of vertical line is representative of a batch of requests. And the blue part is time spent in the Ruby interpreter. So that's my code, basically, right? The yellow part is time that is spent in Active Record and or the Postgres database. So one of the things that this is telling me is like, whatever request is occurring here, if I want to make it faster, it's not the database's fault. It's my fault. I need to be looking at what code is running here that accounts for the majority of the cost of serving that request. I have an Apdex score. It's 0.85, but that's kind of cheating because the tier of New Relic that I have is measuring Apdex over a short interval. You can actually see that I've had some downtimes here, and that's the anecdote that I'm going to talk about, is like, why are there downtimes here when I'm getting a 0 Apdex score? A 0 Apdex score basically means your app is down. It's either down or it's so slow that it might as well be down. So I'll tell you why that happened. It also tells me things like security vulnerabilities. Remember, one of the reasons for doing platform as a service is that they take care of detecting things like, what are these critical vulnerabilities? It looks like there's a couple of libraries I'm using that are vulnerable to request forgery if I'm not careful. Gibbon, for example, is a library that uses the MailChimp API to do stuff. So it's a gem that lets me use MailChimp to schedule email sending campaigns. It looks like there's a security vulnerability that a later version of the library might fix. So that's kind of cool. I can see what my throughput has been. The app is very low usage during the day until the evening because its peak usage times are sort of late afternoon, evenings, and weekend afternoons. And if I go down here, make this a little bit larger, I can actually see, so this is specific controllers and specific actions within those controllers. It's showing me the 5 slowest transactions by total time. I can probably drill down into one of these transactions and see what makes it slow. So here's all the instances recently of this transaction, and it's broken down by all of these different places. Like, where is the dark purple part here is rendering. So the view is actually being rendered. The blue part is time spent in the controller action. The green part is time spent on the way out of the controller action. So basically, I'm getting a breakdown of all the different places where the transactions are going. And so the message here is, if I want to make this transaction faster, I can sort of focus on either of these two chunks. Like, there's a rendering part and there's the controller action. But there's probably other transactions where focusing on the rendering doesn't do anything because that's not a significant part of the transaction trace. So one of the things I was asking here, what was going on in some of the places where my Apdex was 0, and the Apdex score went, there we go. So there were a bunch of times when it looks like the server was bouncing up and down, right? Where my Apdex was 0 and then it went back up to a really good number. So what was going on there? The other thing that I have set up besides New Relic, and by the way, this is monitoring as a service. This is a plugin that's installed in my app, and it's collecting information, sending it off to the New Relic software as a service that lets me have all these panels and views and alerts and reports and stuff. But in addition to that, I also have logging as a service. So my application's logs are continuously being monitored. They're being collected and shipped off to a service where I can search for things. And what I had noticed when I started installing something that whenever the app was unresponsive, like the Apdex score was going to 0, that I would have a notification sent to me by email. And whenever I got one of those, as soon as I could, I would run over to the logs and I would look in the logs for the place where the email was timestamped and see, like, what's going on? Can I tell anything from what's happening in the logs? And the logs were showing that there was a timeout. A timeout is really bad because the timeout on this app is 15 seconds. That means that a user did something and after 15 seconds, they hadn't gotten a response. So clearly something's wrong. I used that information to go into the logs and say, okay, well, what events are correlated with the timeout? And I started seeing events that said memory quota exceeded. So basically, I had my app configured with a certain amount, like a certain number of processes running the web server. I have like 2 different dynos. Each dyno has 2 threads. But something was happening where even though things seemed to be running fine, all of a sudden something happened that made it run out of memory. Anybody know what happens when a process runs out of memory in the Unix world? It starts swapping, right? And if you took 61C, you might remember this. Sorry, Win62, you might remember this. The process doesn't die, but because it no longer fits in memory, parts of memory are getting swapped out to the disk and then swapped back in when they're needed again, which takes orders of magnitude longer than if the data stayed in memory. So basically the process continues to run, but it becomes unusably slow. What happens when, or project here, what happens if you've got a web server with a fixed amount of capacity, like it can handle n flight requests that are in flight at the same time, right? So it sends a request to the app server, and now it's going to wait for an answer to come back, but it's got a fixed number of empty buckets, and it can't reuse a bucket until some request finishes. So what would you expect would be the consequence of one of the app server processes going into swap? We're learning how to debug here, so. What happens if the web server sends a request to the app server process and it expects a response usually within a second or two, and now 15 seconds are going by and nothing's happening? What else is going on during those 15 seconds? More requests could be coming in, right? And those requests have nowhere to go because at some point the web server's queue will fill up because the app server hasn't responded, allowing one of those queue slots to be reused. So there was a timeout, but the timeout was really caused by the memory quota being exceeded because the process was swapping. That's the reason that at that point my AppDex went to 0. Because at that point, the app behaves the same way as if it wasn't there. You try to send a request and it just never responds. So the real question is, why was the memory swap happening in the first place? And I was able to use the New Relic dashboard to trace it to a particular type of operation. There's a particular report that users run very, very rarely. But when they run it, the report uses a lot of memory. The problem is that the way that a garbage collected language like Ruby works, and now we're getting into the guts here, right? This is why software engineering and programming are different. Anybody know how languages work that have dynamic memory allocation? Like Java, for example. C++ is explicit. You have to allocate the memory, and then you as the programmer have to free it when you're done with it, right? So Java has implicit memory allocation, which is, oh, I want a new one of these. What happens over time as you create more and more new things? They have to be garbage collected eventually, right? And so there's a garbage collection issue in Ruby that once this query has happened, the query doesn't take that long to do, but once the query has happened, it balloons the amount of memory temporarily, and that memory never gets freed. So that memory, even though the query doesn't happen very often, if it happens once, the only way to reclaim that memory is to restart the dyno, right? Basically restart the app server. So once that happens, it's just a matter of time until it runs out of memory, which means it goes into swap, which means it times out, which means my AppDex goes to 0, which means I get an email. So my temporary solution is there's actually a little monitoring agent now that watches the logs. And if it sees the memory quota exceeded error, which means that the process has gone into swap, and if it persists for more than a minute, it just shoots the dyno and starts it over. I know, not the most elegant thing in the world, right? It's like just kind of like using a sledgehammer. But at least for now, I know that the problem won't, within a minute, the problem will be detected because there's basically every minute I'm looking at the logs to see if something happened. The real fix is I need to go fix that query. I need to figure out why it's so slow and if there's something I can do to fix it so that the users can still get the same functionality, but with a query that doesn't take a long time to do, or a query that doesn't take a lot of memory the first time you do it. So that's a real life story of application performance monitoring, right? Where we began is once in a while my AppDex goes to 0 and I don't know why. And where we end up is there's a very specific query that is rare, but when it happens, it eats a lot of memory. I now have to drill down into that query and figure out how can I achieve the same functionality, but without having a query that is so memory intensive.